A single honeybee colony can at the same time function as a queenless colony and as a Queenright colony, not by permanently dividing it into two separate colonies, not by removing the queen, but by changing how one section of the colony perceives her presence. Inside the darkness of the hive, the queen is not simply an individual bee that workers can see or touch. Her presence represents biological information. Queen-derived chemical signals are distributed among workers through direct contact, antennal contact, food exchange, and the continuous movement of bees throughout the colony. As long as that information is distributed normally, the bees behave as part of a Queenright colony. But when access to those signals is sharply reduced in one section of the hive, the behavior of the bees begins to change. Young nurse bees continuously evaluate the condition of the colony. They feed larvae, they regulate brood temperature, they process and distribute food, they touch other bees, and through thousands of these contacts they receive information indicating whether the queen is present. When access to that information weakens or disappears, the bees do not wait long. Their response is biologically urgent. If suitable young larvae are available, the colony begins preparing to produce a new queen. This is the response used by the method known as the Cloake Board. A removable solid divider positioned between two hive bodies can temporarily interrupt physical communication between the bees in those two sections. The queen remains in the lower section. The upper section becomes functionally queenless. The availability of queen-derived signals in the upper section is sharply reduced, and the bees begin reacting as though they are queenless. For the bees above the divider, the queen is no longer functionally present, even though she still remains in the lower section of the same hive. The system carries the name of Harry Cloake, a beekeeper from New Zealand. His idea addressed one of the central difficulties of controlled queen rearing. A colony that strongly starts queen cells usually needs to respond as though it has lost its queen. But a permanently queenless colony gradually becomes more difficult to manage. Its organization changes. The queen is no longer laying eggs. New generations of workers are no longer being produced. The number of young nurse bees decreases over time, and a colony that was initially powerful and full of energy slowly loses the biological foundation required for sustained queen-rearing work. Traditional systems, therefore, often use separate colonies. One colony serves as the starter, another colony serves as the finisher. The starter is queenless, densely populated with young bees, well supplied with food, and prepared to accept the larvae introduced by the beekeeper. The finisher is Queenright, stable, organized, and capable of continuing the care of queen cells that have already been accepted. Such a system can work extremely well, but it requires more equipment, more bees, more hive bodies and frames, more feeding, more inspections, and much more precise coordination between two separate colonies. Cloake's solution was elegant. Instead of maintaining two separate systems, he created both biological states inside one powerful colony. For a limited period, the upper section could function as a densely populated queenless starter. Later, that same section could be reconnected with the Queenright colony below and become a stable finisher. The same bees, the same hive, the same resources. But two different biological responses, activated at precisely selected moments. At first glance, the equipment is simple. The Cloake Board is a frame positioned between the lower and upper hive bodies. It contains a queen excluder, which keeps the queen in the lower section while allowing worker bees to pass through. Above or alongside the excluder is a groove that accepts a removable solid divider. When the divider is removed, workers can move between the hive bodies. The colony remains connected. When the divider is fully inserted, passage between the two sections is interrupted. The upper hive body has its own entrance and becomes a temporarily separated, functionally queenless unit. But simple equipment does not mean a simple procedure. The Cloake Board is not a switch that automatically produces high-quality queens. The divider only creates the necessary conditions. The result depends on colony biology, on colony strength, on the number of young bees, on the amount of open and capped brood, on pollen and nectar availability, on the age of the larvae being introduced, on temperature, on the sequence of operations, and, more than anything else, on timing. Before the process begins, a strong and healthy colony must be selected. A weak colony does not become a good queen-rearing colony simply because a specialized divider has been placed between its hive bodies. A large population is required. A substantial number of young nurse bees is required. Adequate pollen and honey reserves are required. If natural forage is not consistently available, the colony must receive appropriate supplemental feeding. Queen rearing is biologically expensive. A future queen larva must be fed intensively with royal jelly. Without an abundance of food and nurse bees, queen cells may be accepted, but their development may not reach the level of quality we expect. The queen must first be located and safely confined to the lower hive body. The queen excluder prevents her from moving into the upper section. This is not a detail that can be assumed. The beekeeper must physically confirm where the queen is located. If the queen remains above the excluder, the upper section will not become a queenless starter. The biological logic of the entire system will then fail. The arrangement of frames also has a specific purpose. Enough brood is placed in the upper hive body to attract young nurse bees. A pollen frame should be positioned near the location where the grafted cell bar will later be placed. Food must be readily available. The space in which the bees will care for the developing queen cells must be warm, densely populated, and heavily covered with bees. It is not enough for bees simply to exist somewhere inside the hive. They must be in the correct location at the exact time they are needed. The way bees enter the hive is then changed. The position of the entrance is not merely a construction detail. Foragers remember the location to which they return. When the direction of the entrance is changed, some returning bees can be redirected into the upper hive body. This concentrates an even larger number of bees above the cloak board. The upper section becomes crowded. The population of nurse bees increases. Pollen and nectar continue to enter through the upper entrance. The system uses the natural orientation behavior of honeybees to build a powerful starter without shaking an entire colony into a separate box. Once the colony has been prepared, the removable solid divider is inserted into the cloak board. At that moment, one colony becomes functionally divided into two sections. Below remain the queen, brood, and part of the colony population. Above remain young bees, brood food, and redirected returning foragers, but without direct physical connection to the Queenright section below. The availability of queen-derived signals begins to decline. Bees in the upper section inspect the larvae. They move across the comb. They touch one another. They search for information that had previously circulated normally among them, and they no longer receive it at the same level. The upper section now enters the starter state. That state is not simply the physical absence of the queen. It is a change in the priorities of the entire biological system. The bees begin behaving as though the survival of the colony depends on producing a new queen. It is inside this biological window that carefully selected young larvae will be introduced. But success will not depend only on whether the bees build queen cells. The real question is, what kind of queens will develop inside those cells? Once the queenless response in the upper hive body is sufficiently established, a frame containing queen cups and very young larvae is placed in the center of that section. The larvae must be of the correct age. The younger they are at the moment of grafting, the more time the bees have to direct their development toward the complete physiology of a queen. An older larva has already spent a greater portion of its development under the feeding program of a worker. Its developmental pathway may therefore be more limited. Precision in selecting larval age is not unnecessary perfectionism. It is one of the foundations of queen quality. Grafting, however, is not the only way the cloak board can be used. The method can also be adapted to systems that use prepared queen cups, kits that provide larvae of known age, or carefully selected natural cells. Regardless of the technique, the biological requirement remains the same. The bees must receive a larva young enough to be developed into a physiologically complete queen, and that larva must be surrounded by a large population of young, well-fed nurse bees. When the frame enters the starter, nurse bees begin inspecting the cups. Some larvae are accepted, others are rejected. Accepted larvae receive an abundance of royal jelly. The bees extend the walls of the cups. The queen cells begin growing vertically. During the initial period, the queenless impulse drives strong acceptance. The colony does not build those cells because it understands the beekeeper's plan. It responds to a biological problem that has been deliberately created. But the queenless period should not continue longer than required for the starter function. Once the larvae have been accepted and queen cell construction has clearly begun, the removable solid divider is taken out. The upper and lower sections are reconnected. The queen excluder continues to keep the queen below, but worker bees can once again move throughout the connected colony. Physical and chemical communication is restored. The upper section is no longer a completely separated queenless unit. It becomes part of a powerful Queenright colony and enters the finisher phase. This is the core of Cloake's solution. Queen cells are started under a strong queenless impulse. Their continued feeding and development take place inside a stable, organized Queenright colony. The starter and finisher are not two different hives. They are two consecutive functions of the same colony. During the finisher phase, quality does not depend only on the fact that the colony has been reconnected. Nurse bees must still have access to adequate pollen. There must be a continuous supply of food. The queen cells must remain densely covered with bees. Temperature must remain stable. If the colony is hungry, too weak, or exposed to a sudden drop in temperature, the presence of a queen in the lower section will not compensate for a lack of resources. Biology does not respond to the name of the method. It responds to the actual conditions inside the hive. Throughout the procedure, the frames in the upper hive body must be inspected. When the bees are temporarily deprived of normal access to queen-derived signals, they may not use only the larvae introduced by the beekeeper. If suitable young larvae or eggs exist on other frames, the colony may begin building its own queen cells. Those cells can create a problem, not because they are necessarily poor quality cells, but because they interrupt control over queen origin. The beekeeper can no longer be certain whether the first queen to emerge will come from a selected larva on the cell bar or from a hidden cell on another frame. The inspection must therefore be thorough, every frame, every comb surface, without assuming that unwanted queen cells will appear only along the lower edge of a frame. Another critical point is the complete closure of the solid divider. If a passage remains between the two hive bodies, the upper section may not develop a sufficiently strong queenless response. A few workers moving through a small gap may not appear significant, but the entire system is based on controlling communication between the two sections. The divider must seat properly inside its groove. Wax, propolis, or irregular comb must not prevent complete insertion. The construction must maintain appropriate bee space while preventing unintended passages between the sections. An incorrect evaluation of colony strength can also produce weak results. A hive may appear crowded when it is opened, but that does not necessarily mean that it contains enough young nurse bees. A large population of older foragers cannot fully replace bees of the correct physiological age. The production of royal jelly and the intensive feeding of larvae require young workers with well-developed glands. This is why the arrangement of brood is used to attract and retain nurse bees in the upper section. Nutrition is another point at which the method can either succeed or lose quality. Pollen provides proteins, fats, vitamins, and minerals required by young bees. Nectar or sugar syrup supplies energy. When a strong natural nectar and pollen flow is available, the colony operates under conditions of abundance. When forage is limited, the beekeeper must carefully determine whether supplemental feeding is required. The goal is not merely to prevent starvation. The goal is to create conditions of sustained abundance inside the colony, because producing a high-quality queen requires much more than minimum survival. The timing of divider removal must also follow the selected operating protocol. If the colony is reconnected too early, the queenless impulse may not be strong enough to produce good acceptance. If the separation continues too long, the upper section may begin building numerous emergency queen cells, lose stability, or remain unnecessarily separated from the resources of the lower section. No single number can replace observation of the actual colony. A schedule provides the operational framework. But the condition of the bees confirms whether that framework has been applied correctly. As queen cells approach capping, they enter developmental periods in which they can become particularly sensitive to rough handling, sudden rotation, impact, and loss of heat. A frame should not be turned abruptly. Queen cells should not be left outside the warmth of the colony longer than necessary. Later, before the first queen emerges, mature queen cells must be transferred into mating nuclei, nucleus colonies, or appropriate protective cages. If several mature queen cells are left unprotected inside the same colony, the first queen to emerge may destroy the others. The method therefore does not end when the bees cap the cells. It ends only when every mature queen cell has been safely distributed according to the beekeeper's plan. The cloak board can be used for multiple queen rearing cycles during a season, but only if the colony remains sufficiently strong. Each cycle consumes energy, food, and labor from the bees. It is not professional practice to repeat the procedure simply because the equipment allows it. The colony population must be reassessed. The amount of brood, food availability, the condition of the queen, the health of the colony, and the point in the season at which the work is being performed. The quality of the future queen is not determined only by the rearing method. It is also influenced by the genetic origin of the larva, the health of the colony from which the larva originated, the number and quality of drones in the surrounding area, weather conditions during mating, the strength of the mating nucleus, and the later management of the young queen. The cloak board solves one very important part of the process, creating a powerful cell-building system. But it cannot compensate for poor genetics, an inadequate drone population, or weak mating nuclei. For that reason, the Eterna system does not view the cloak board as a trick. It is not a divider that automatically produces queens. It is a tool for managing the biological state of a colony. The beekeeper does not command individual bees. The beekeeper changes the conditions under which thousands of bees make collective decisions. The flow of information is altered. The colony population is redirected. Nurse bees are concentrated. The queen's physical location is controlled. And the natural queen rearing response of the colony is activated at the moment selected larvae are introduced. This is where the true engineering of the method is found, not in the wooden frame, not in the removable divider, not in the handle used to insert or remove it, but in understanding that a honeybee colony responds to information, to bee density, brood, food, space, and the functional presence of the queen. When the solid divider is inserted, the upper section receives the biological message. Normal access to the queen and her signals has been interrupted. When the divider is removed, the colony becomes connected again. When nurse bees are concentrated around young larvae, intensive queen cell construction begins. When enough food and heat are available, care continues. Every step involves a physical action. But behind every physical action is a biological response. The most common failures occur when the equipment is seen, but the system is not understood. The queen has not been located with certainty. The upper section does not contain enough young bees. The solid divider is not completely closed. Unwanted queen cells remain on other frames. The larvae are too old. Food is inadequate. Timing is followed mechanically, without evaluating the actual condition of the colony. The cloak board may then be physically present inside the hive, but the method has not been biologically established. When all conditions are properly aligned, one powerful colony performs work that would otherwise require two separate colonies. First, it responds as a queenless starter, then it continues as a stable Queenright finisher. The bees are not deceived in the simplistic sense of the word. They respond precisely to the biological information available in their environment. The method works because it respects that logic. Harry Cloake did not remove the complexity from queen rearing, he organized it. He reduced the need for separate colonies. He connected the starter and finisher functions within one system. And he demonstrated that a simple piece of equipment can become a powerful biological tool when it is synchronized with colony biology. One colony, two biological states, one removable solid divider, but behind it, thousands of bees, millions of contacts, and a precise sequence of collective decisions. This is the Cloake Board system, not a method based only on equipment, but a method based on understanding a living system. Continue exploring the Eterna system. Read the latest issue of Eterna Journal for deeper seasonal analysis, scientific context, and practical beekeeping strategy. Download the August Colony Audit Checklist and use it in your own apiary to evaluate colony strength, brood, food reserves, queen performance, and seasonal risk. Then continue watching the Eterna System documentary series, where each episode connects equipment, biology, and practical management into one complete system. Subscribe to Eterna Studio, turn on notifications, and join us for the next episode. Because better beekeeping begins with understanding the colony, not just the hive.